Okay, I think we can start. Okay, so good evening or good morning, everyone, or depending on where you are located, obviously. My name is Martin Bat. I'm support engineer at IXUS, and I'll be presenting this webinar today just on 3D RF compliance, essentially using IXUS, the IXUS software. Yeah, so just some background on me. So I started at IXUS about 2 years ago as a support engineer. Yeah, but my history is pretty much grounded in EMF compliance. So since for the past, let's say, decade or so, but more than a decade, I've been essentially doing work in RF compliance for one of our sister companies. It's also part of the Alpha Wave group. Yeah, essentially doing from the ground up, visiting sites as well as doing assessments using software and so on. Okay, so yeah, today, as I mentioned, this is just a presentation on how we would do 3D compliance using the 3D tool that is IXUS. And yeah, as mentioned, the Q&A section that you can put your questions there. Okay. Yeah, so just a quick overview of the topics that I'll be discussing. So essentially going to start with just a question regarding assessment of exposure versus assessment of overexposure, and those two topics might seem like the same thing, but it's a bit different approach. I'll go through the pros and the cons of both of those approaches, and then move on to the 3D representation of compliance exclusion zones and how that works in IXUS. And then following that, going into how we would use these 3D compliance exclusion zones in combination with the Lobe imprint feature to essentially determine where compliance overexposure areas are. Also touching on the environmental slices and the field points where we would typically want to use those tools for exposure analysis, and typically best catered for points of interest, and as well as looking at the attenuation options as well as the operator contribution options for those environmental slices. And just after that, just moving into, after we've established our compliance zones, then we can look at mitigation strategies and reporting, again using the IXUS tool and its various functions. Okay, so assessment of exposure versus overexposure. So by looking at the pros and the cons of each of these, so the assessment by determining exposure. So what does that mean? So essentially what we would be doing there is looking at areas that we want to assess and then determine what is the exact exposure at those areas. So that's a fairly good positive point of these, is that it gives you exact exposure levels of the area that you're assessing that can then be used in the reporting and stuff like that. Another pro is obviously this quantifies exposure at the assessed areas. So as I mentioned in reporting, it's sometimes useful to give a number to what the assessment area is. So if we look at some negatives, so it can be a slow procedure of calculating the exposure at each area of assessment, since obviously you need to determine, we need to establish all those areas of assessment as well. And the next question is then, where do you stop assessing? So once you've start identifying areas that you want to assess, where do you actually stop? Which surfaces do you stop assessing? And that can lead us to this the main negative point of this is unnecessarily assessing areas of low exposure. which obviously then wastes time of the assessor. And if we now look at the assessment by determining overexposure, so again, as I mentioned, it sounds like the same thing, but it's a bit different. And it essentially, actually, with the previous approach, we would also look at overexposure, but first determining the exposure. So the pros of this is then where it limits the calculations and the calculation time to only the overexposure regions. So we're not looking at all areas or that needs to be calculated. We're only looking at these overexposure regions. Okay, so this can save assessor time as detail can be limited to these problematic areas. And as I mentioned, also calculation time. Then you can also use this, especially in combination with something like the Lobe imprint tool, to easily identify areas where mitigation is required. So as I mentioned before, the previous approach is where we'd be determining exposure, where here we're only looking at areas where there is overexposure. And those are essentially the areas where mitigation is typically required. So the negative of this is obviously that this does not give you does not quantify the exposure at that area, but rather only indicate where exposure limits are exceeded. And then I'd like to quickly show a bit of a modeler demonstration of a rooftop site. Is actually and it is an actual site. This it's a bit modified, but I think it should give us a good understanding. All right, so first of all, we're looking at this model. This is the IXUS modeler, and we're looking at this model now from a top-down view. And already we have this amazing functionality that since this is now a free-day tool, we can look at this model in 3 dimensions, and we can have a much better perspective of what this rooftop looks like. However, as you can see, the antennas are located here on this, it's probably an elevator shaft of some sorts. And these antennas would then typically radiate from there. And there would be areas where the exposure to those RF fields would be exceeding the particular guidelines. So the problem now becomes, where do we actually stop assessing? Which surfaces do we need to analyze to determine if that area is going to be overexposed? And then if we start looking at the blueprint of this, which is a satellite image of this rooftop, we'll start seeing that there's lots of other structures around this rooftop. So here's a lower rooftop, and another one, and another one. And then we can also start looking at neighboring buildings. So here's one that's already created. And there's obviously some houses here at the bottom. And on this side of the road, there's additional structures. Do we need to analyze those? So it gets to a point where, and obviously we can expand on this satellite image and make it broader. But in an ideal situation, we would be able to assess all of these regions. However, that is not very viable in terms of a production environment. We would want to save time of the assessor. So we can go and assess each of these surfaces to determine what is the exact exposure, but obviously that's going to take a lot of time. So what we can rather do is just find out where the areas of overexposure is. Okay, so now I'll be looking at this 3D representation of compliance exclusion zones. So if we look at that same rooftop, in this picture over here, I've added a few of the levels that I mentioned, the lower levels. And you can go place environmental slices on these levels to determine what is the exact exposure. But as you can see, these white environmental slices, which is 0 to 5%, you'll notice that that is actually very low exposure. So an alternative to this is using the 3D representation of the compliance exclusion zones. So these are, as mentioned, the overexposure zones. So, okay, for all our international clients, this specific rooftop is actually one that is located in the United States. So the exposure standard that would be relevant in this case is obviously then the FCC OED 65. So that uses the public exclusion zone as a blue exclusion zone, the yellow as the occupational, and the red as a 10 times occupational. So what these 3D exclusion zones then represent is that a person should not be able to enter these exclusion zones. Well, for the blue, obviously a member of the public, because that would mean that they are being overexposed. So that's now a very nice way to now see where the overexposure areas are and where we should avoid people getting to that location. And already we can now see that a lot of these other surfaces that we have created, like for example, this structure over here and over there and over there, is actually quite far away from our overexposure areas. So just by looking at this picture, we can already see that we do not need to apply a lot of detail to these structures here at the bottom. Just giving it a very standard height, just to show that the distances from the exclusion zones to the surface is quite far, already established that this is not going to be a problematic area. However, here at the top, we can see that this roof level over here is obviously going to be an issue, and we might want to consider to add additional detail in this area and this area if necessary. So by looking at these exclusion zones, it looks like there might be overexposure areas, but it's still difficult to actually determine if there's any accessible overexposure areas. So what the tool is that we like to use in IXUS is called the Lobe imprint tool. So what the Lobe imprint tool does is it actually uses the geometry that you've created in your model, and it uses the 3D exclusion zones that you've now created. And everywhere where the 3D exclusion zone, the separation distance to the geometry is less than the specified amount, it would imprint. And essentially then showing that all the surfaces where if a person would stand, and obviously that the length of that person is determined on your guidelines. In this case, it's the standard that's using is FCC OED 65. That is using 6-foot spatial averaging, and also then analyzing a 6-foot person. So we can use a Lobe imprint of, well, actually 3 foot, because we're looking at this center evaluation point of this 6-foot spatial averaging range, and then determine where the surfaces are if a 6-foot person would stand, where they would be overexposed. And then we get to this next slide. So now by running the Lobe imprint, we can see that all these surfaces over here and over here are actually they're not overexposed. So there's no overexposure areas over here. The only overexposure areas are here on this main rooftop, and they're on top of that access point. So we also don't need to add a lot of details here at the bottom, because we've already established it's far away from the zones. These heights would be important, but there's no mitigation necessary in these areas. So then we get to the environmental slices and where they are particularly useful. For example, this elevator, or not elevator, sorry, this access point that I'd mentioned, the 3D exclusion zones actually entered this piece of the building. And what we can use there is then an environmental slice coupled with an attenuation level, depending on obviously what type of structure this is and what type of material. And we can add in a custom attenuation level to establish that the exposure inside of this structure is actually going to not be overexposed. Additionally, if there's now let's say a large neighboring building, typically when you have an assessment like this, you often get this members of the public that might be concerned about these antennas that are located just across the road. And typically in those cases, when you tell these people that yes, this site is compliant, that's not typically going to be a good enough answer for them. They would want to know, no, what is my exact exposure? I'm not happy just by the answer that yes, you are fine. We want to know what is my exact exposure. And in that case, we can use a vertical environmental slice, again using the spatial averaging scheme, and then determine where's the maximum exposure anywhere on this neighboring building. And then we can see that this is 26% and it's not overexposed. We also have the option of adding an operator contribution option to the environmental slices when there's multiple operators and you want to determine if the overexposure areas are specifically due to your operator or the other operator. Then you can essentially toggle which operator you want to assess. Okay, so then I'll just do another modular demonstration, just showing that identifying areas of focus and so on. Okay, so here we are back to our rooftop. So what I'll do now is actually enable the 3D exclusion zones. So I've already simulated this, so I don't have to wait for 2 minutes for it to simulate. And as I mentioned, this is using the FCC OET 65 with a 6-foot spatial averaging scheme. So by looking at this, we can now establish that this, as I mentioned, this area over here is definitely going to be an area that we want to assess very closely. And we would want to know exactly the height of this structure over here, and maybe this, it's going to be important things to establish. If I now look at the top view of this 3D exclusion zones and the building, we can now start seeing that where we want to maybe add additional structures to our geometry. For example, here, this piece of the building over here, because the blue is now above that, we might want to add that. But because we know the exclusion zones are actually quite far here above, it's not going to be anywhere near this structure over here. We can still add it, but we know we're not going to add a lot of detail. For example, I'm not going to add the, I think that's probably an aircon, air conditioning. I'm not going to add that much detail because that's just wasting time. Similar to this rooftop over here as well. So I can add these structures, but because I know it's very far in vertical distance from these exclusion zones, I don't have to spend a lot of time and effort with detail there. However, it would be very, as I mentioned before, it would be very important to add the detail in this region. Now, this is actually. Okay. So once we've now established this, then we can use the, as I mentioned, the Lobe imprint tool, which is this tool over here, and we can specify the height, the separation height for this. And because we're using a 6-foot spatial averaging, we would want to use the center reference point for that 6 foot, which is 3, and then we can run that to determine the Lobe imprint. So I've already run that, so I'll just show that. And then we can hide this. So now we can see that the overexposure areas are here on the rooftop, and here on these levels, the exposure it's not overexposed. So we already know we don't have to apply any mitigations in this area. So the next thing that we might want to do is then, as I mentioned, the points of interest. So over here we have the neighboring building that we can add environmental slices to. And that then established that the exposure on these buildings is 26.75%. So as I mentioned, you probably would not need to add this or do this analysis. But when there is public perception involved, often, as I mentioned, they would not simply be happy with the answer of yes, you are compliant or you're not being overexposed, as well as the inside of that building, which is over here. So as I mentioned, we can also use a vertical slice to determine the maximum of any area over here, and we can apply a, let's say, 6 dB attenuation to take into account the attenuation through that concrete, and then we can establish that that is also below the standard. So then obviously we can see that we do need to have some mitigations here, because if our 6-foot person would now walk from here to here, he actually would be overexposed. So we'd want to add some sort of protection there, or barrier, or whatever the case may be. And that takes us to our next section. Mitigation strategies and reporting. So as I mentioned, we've now established that the overexposure area on this rooftop is over here. And we would want to add some sort of protection there, or signage or access control to limit members of the public entering that area and being overexposed. So to do that, we can, for example, in this case, we've added a railing as a physical barrier, and then also installed some signage to indicate that this area should not be accessed. So this typically is then obviously a good representation of what needs to be done, but often in reporting, you'd want something that stands out a bit more in terms of for this physical barrier. So what we've implemented recently is adding the line annotation feature, where we can add a line of various different styles and colors, and we can add it over here to indicate that this area is for example, a proposed barrier. And then if we look at the top-down view, then it's obviously nice and visible. Whereas with a railing, it's not necessarily going to be that visible. So once we've established this, we can essentially go on to adding pictures and then doing a report using the IXUS manager. Okay, so then I'll just do another demonstration quickly. Okay, so in terms of the site that we've now assessed, we can see that we need to add a barrier of some sorts in this area over here. So as I mentioned, the thing that I've added there is a railing as a physical barrier. And let's actually hide these Lobe imprints quickly. And then together with this railing, obviously not just a physical barrier is not necessarily going to keep a person out of this area, we can also add signage to this barrier, then indicating that we need to add signage in this area as well. So the combination of the barrier and the signage should keep any members of the public out of this area. So the problem that we had with this approach when doing the pictures for the reporting is that the railing is often not going to be very visible in pictures, especially if viewed from afar. So what we have included with with the release that's coming out next week, so that's just a quick sneak peek, is this line annotation feature. Essentially that you can set the specific styling and the marker styling, the marker spacing as well, and the color, etc. So this then is a nice visible line or annotation essentially for your reporting to show that this area needs to be demarcated with a barrier. And this can obviously, for your reporting purposes, can mean whatever you put in your template. So after we've now established where we need to demarcate or add specific signage, then the next step is actually to prepare this site now for reporting. So in that case, what we would do is start adding pictures in our modeler. For example, over here we have a site plan picture that just essentially a picture of what the building looks like from the top, and an overview picture also indicating some access points, a side view, and then we start looking at pictures of the exclusion zones, and again indicating the satellite image below, so that in the report you can see that essentially anything that is beyond these blue areas we don't really need to assess because the value is going to be less than the guidelines. And there's a side view just to indicate the elevation differences, and then we can have a exclusion overview, and then we can start having our pictures of the lobe imprints, essentially indicating where the overexposure areas are. And as I mentioned also that you can also add apologies. Yeah, so you can also add environmental slices to essentially quantify what the exposure is at specific areas. In this case, I also added some environmental slices on the actual rooftop so that I can, in my report, show what the maximum exposure in this area is, and over here on top of this little access point. And then obviously as I mentioned, the neighboring building, the roof access, and my implementation that I want to include. So once I've done all these pictures, I can then save this back to the manager, which is this website over here. So there's my base station. So I'm not going to save it right now. It's already saved. Once you also then populate all the necessary details over here, for example, the base station name, the street address, the lat long and stuff like that. And importantly, for example, the signage comments, so what the current signage is. And these things you would, depending on the reporting template that you're using, is you would need to populate those. The access control comments, the compliance certificate comments, so essentially what the compliance status of the site would be or is at the moment, and then some additional comments for what the recommendations for this, the implementation recommendations for the site is. Oh, and as well as I've also added a picture of our offices in Stellenbosch which I'll just use as a front page picture. And if we can now go to IXUS reports, we can click generate, and we can choose our report template. And this is again just a review of the comments that we've already added. Adding our front page picture. And then the scale maps. So again, this is depending on the template that you're using. So these ones I want to include there. And then the 3D emissions. So these are essentially different groups of pictures in my report template. And then the recommendations. So I actually want, this looks fine. So once we've chosen all our pictures, we can save this report. So again, this is a Word document, but using a Word document template. It then saves it in the manager, and then you can, then essentially the reporting is done. But since it's a Word document, you can actually download it and edit it if necessary. Okay, so there's our report. And again, this is just a generic template that I have. So there we have our site name, the address, the lat long, as well as the compliance statement. And here we have our maximum predicted spatial averaging value on the site. And our current mitigations, RF signage implementation. So there's no signage at the site at this moment. Door leading to rooftop is locked. So again, these are content controls that are essentially being populated from the information that is available in the manager, as well as the IXUS version used. And then we can get to our pictures. Our antenna inventory, and our environmental slice data. So these are, as I mentioned, the points of interest that I wanted to show exactly what the exposure value is. So these are the values that you can see over there. So there's the two, the upper rooftop and the main rooftop, and so on. And then we have our overexposure areas, as well as our environmental slices that we created, and our recommendations. Okay, that's essentially it. Okay, so in conclusion, so what we can do is you can speed up your compliance assessment by focusing on overexposure areas instead of looking at the specific exposure for all the areas that you want to assess. So using the 3D compliance exclusion zones in combination with the Lobe imprint tool allows assessors to quickly and easily identify areas of concern where mitigation may be required. And as I also mentioned, environmental slices and field points can be used to provide additional exposure detail for points of interest. And then obviously the IXUS Manager's reporting feature in combination with the modeler functionality allows a seamless reporting for the assessor. And that is the presentation. Thank you very much.